I'm Simon Swift. I'm Engineering Director for ETL Systems, looking after our digital product lines. Included in this is our new groundbreaking Genus Digital IF digitization platform. ETL has been a provider of RF distribution systems for many years into all parts of the satellite industry, and you'll find our equipment at practically every satellite earth station around the globe. So what is Digital IF? Digital IF is a new groundbreaking technology which allows RF signals to be distributed over IP, Internet Protocol. So how does this work? Well, it starts off with digitizing a signal at high speed using ADCs or analog digital converters, and then converting that into an IP stream which can be sent over high-speed Ethernet. Now, at the far end of that high-speed Ethernet, we use a digital to analog converter, or DAC, which in turn reconstructs this IP stream into an RF signal. The key benefits of Digital IF are manifold. Firstly, it's enabling what we call virtual network functions. This means that things like modems and signal generators and other analysis tools can actually be hosted in the cloud or on standard compute platform, giving a huge benefit of flexibility to the end user. Modems now become an OpEx question instead of CapEx. Signal quality is another interesting improvement here. Whereas previously, every single additional piece you put into an RF signal chain degrades its quality slightly, with Digital IF, you manage all of that signal degradation right at the front end. The key things here being the parameters of the ADCs and the DACs. Bringing the routing into the IP domain gives a lot of flexibility. Previously, we'd have had to establish switched paths over which we'd route a signal. Now, the routing just becomes changing the IP address. And no matter how far you send it, no matter how many times or how many people you send it to, the signal quality always remains the same in that IP domain, which leads to a huge improvement in system resilience when you can reroute so easily. Finally, in the secure domain, it allows us to remote an antenna from other analysis equipment. So, for example, if you have some key crypto equipment that needs to stay on home ground or in a secure area, that can be facilitated because suddenly you have the ability to transmit this signal easily over distance. Okay, just returning a little further now to where we're going to use this. We talk about virtual network functions, virtualization of modems. Why would that be useful? Well, apart from the obvious benefit of moving to an OpEx model instead of a CapEx model, as you upgrade your modems, as new waveforms become available, it's a software upgrade rather than a hardware upgrade. There's obviously green potential with that as well. When you want to stand up a whole set of modems for a particular application, such as a sporting event or even disaster relief, suddenly you can put the right modems on the right satellite for service in the right place on the ground. One of the frequent applications our equipment gets used for is signal diversity. Take, for example, in the tropics where you get big rainstorms coming over. A big heavy rainstorm can absolutely wipe out your RF signal. The way we get around this is by putting what we call diversity antennas. So two antennas very far spread apart, say 100 kilometers, and that mitigates against that rainstorm because it's unlikely that both of those antennas are going to be covered by that same rainstorm at any one time. Typically, we'd have done this with fiber, but that means you've got to amplify the signal, and you degrade that with noise as you amplify it and keep moving it over distance. Digital IF gives that ability to keep that same signal quality regardless of distance. Once you have something in the digital domain, you can do pretty much anything with it. Now, one of the key parts of the Digital IF system is that it timestamps all of the signals as they come through with a very precise timestamp. Now this has huge benefits for synchronizing signals, whether that's with non-geostationary orbit constellations or NGSOs, or whether that's perhaps for geolocation of, say, interferers or emitters that you're not particularly happy with being in the area. So what happens to all of the legacy analog equipment that's already in all of the satellite Earth station infrastructure? This isn't going to obsolete it overnight. We can work alongside the analog equipment, and ETL has taken great pains with the design of its Genus Digital product line to help our customers easing the transition into the new digital age.